This is lesson 18, and we've just finished stairs, so I'm going to talk about modeling some of the built-in furnishings. That is, casework, for instance, in the kitchen, cabinets, countertops, elements that go on the walls, wall cabinets. That is stuff that is not standalone pieces of equipment that could be purchased. So last, you'll remember, we modeled the stair volume that included this transparent footprint, 3D footprint of the space that stair would occupy. So we do need to, if we haven't, create a layer. Let's just simply call it stairs for now. And let's take this component and place it on that layer. It says there are two such components because if you remember, if we were to undo, turn off section cuts, remember we modeled the stair outside of that volume so it would be replicated in the instance of that component inside. What I'm going to do now is change layer visibility so that we can very easily see the kitchen area so that we could model it. I'm going to start systematically turning off layer visibilities for the elements that are occluding our view of the kitchen. I'm assuming at this point in the model you're comfortable doing this. So there's the roof is now hidden, the ceiling on level 2. Let's for now hide as well the stair element. And let's turn on the visibility of the AutoCAD underlay on level 2. Let's turn off the others so they don't, the elevations, sections, and I think that's about everything. So all we have is a CAD underlay which is telling us where the casework in the kitchen lives. I'm going to start, and all this geometry is grouped or otherwise part of a component so that we don't have to worry that we're going to inadvertently stick to stray elements. There's some guides here that we don't need, so I'm just going to double. Let's see if we can select individual guides, walls, interior. Just a few guides that we don't need right now. I'm going to close that group. Okay, and I don't want to turn off the visibility of guides because we need them to draw furniture. So, our casework, that is, built-ins. Let's measure the distance. End of the counter. So we have 2 feet and 1 inch, and that includes something of a 1 inch overhang here, right, for the countertop. But the casework itself is normally about is normally 2 feet in depth. So here's a rectangle representing the cabinets here. Actually, it has something of an overhang. As well to the left. So okay, so there's a 12-inch cabinet that we want to create. I'm going to move this edge along the red axis so it corresponds to the outline, the profile of the 12-inch cabinet. So that's 12 inches wide by 2 feet deep. Let's draw what appears to be another inch cabinet. I'm just going to type in the dimensions explicitly. 12 comma, sorry, yeah, 12 comma 24. Drawing doesn't align perfectly here, and we can later we can fix that. Deal with it. It's 2 feet. This is going to be 2 feet by 2 feet. So let's type 24 comma 24. From here to there will be 24 comma 12. Finally, well, this is going to be a dishwasher on that side. I'm fairly certain. There's a blind base, so we don't need to draw that. That's going to be a separate element. All of this gets extruded to a height of 36 inches. That's going to include the countertop surface, and we'll make adjustments for that afterwards. So for the sake of simplicity, let's go ahead and push that to 36 inches. This may be simplified to its shape. It's actually one 12-inch cabinet plus what appears to be a blind base in the corner. We can deal with it as one group, extrude that to 36. So that will that's the gross rough representation of the under counter cabinets. Triple click that, hold the control key, triple click this, and let's just group those. Create a layer, casework, base, cabinets, kitchen. Let's place those on there. Now there's some tricks that we may use to replicate, because the profile of the wall cabinet is going to be about the same as this. I can take those two shapes, copy them, close this group, edit, paste those shapes in place, and move them up on the z-axis to be the the 18 inches, which is a typical from the top of the counter to the underside of the wall cabinet. Now, of course, the wall cabinets are typically not 2 feet in depth, but 1. So this geometry can be adjusted. We'll take that line and push it in 12 inches. Same here. And the green axis 12 inches. This line, let's push it inward 12 inches on the red axis. So now we have profile for the underside of the wall cabinets. I can take these shapes, and what's typical, 2.5 feet .6. Double clicking just replicates the last push-pull. Okay, so now we need a stove in here. But let's see how we can deal with that. We're going to, because we're dealing first hierarchically with just the built-in architecture that we're building here, we want to get all that out of the way before we bring in elements that are standalone elements that may be installed. So let's triple click, control, triple click that, make that a group, and create a layer. Casework, wall, cabinets, kitchen. And in the next lesson we'll go into the refine. Oh, we're missing one more. The base cabinet for the sink. So we'll show you a quick and dirty way to extend that blind base to accommodate. So there's about 2.9 it forms the width of the sink base. So if I take this face and simply move it in that direction 2 feet 9 inches, it's probably more likely to be 210. Let's see, 24 and 10 would be 34. Let's type in the numbers here. Oops. 34 inches. No, that's too far. Back 1 inch. Okay. Close that group. There's a window above, so that is essentially the base architecture for our built-in cabinets. We'll get into refinements thereof in the next lesson. That's lesson 18, built-ins for the kitchen. Naturally, we would do that as well for the other rooms.